Hello. This will be the fourth video on Pathplanner and PIDs for understanding just how they work in the code team and how we know how to use them. It's a relatively new thing that we're doing using Pathplanner. We figured it out last year, so this will be the video on how to do it. Once you've downloaded Pathplanner in the first video and you've opened up VS Code, you should have access to all of the autonomouses and paths that we've created with our example Pathplanner. The way we do our paths is you want to do each individual segment in the paths, and then you want to combine them together in the autonomous by picking them like this. And then I just have stops in between, but you could easily just turn these off and it'll immediately go from here to the next point as it goes on. The goal of Pathplanner and PIDs is to move the robot as close to the Pathplanner as possible. And the way you do it is you come over here to the drivetrain and then you mess with these PID constants. The goal of these PID constants is to do a trapezoid of movement. Basically, you start off at some point. Let's use the Pathfinder example here from right here. This is your starting point and this is your end point. You want to accelerate when moving laterally, and for turning, it's the exact same process. You want to accelerate up to some certain speed, the speed that you're going to be going on for most of this movement. And then you want to stay at that speed for a certain amount of time. And you want to decelerate as you get closer to the endpoint to make sure you're always hitting that endpoint every single time. Same thing for turning. You accelerate to the max speed of turn, and then you continue on the max speed that you can turn at for as long as possible, and then you decelerate as you get closer to the end. The example should be like right over here. The robot is turning in place, and it'll do the exact same thing with this trapezoid. So the way PID works is you have your initial P, I, and then D. The P constraint calculates how far or how fast it initially goes, and how the distance between the distance it measures between how much left it has and what speed it should be at. The D decreases oscillations. So after your P, once you get to a consistent place of movement, you want to increase the D constraint slowly to decrease the oscillations towards getting that point if you go a little far or a little bit close for both turn and movement. And then I will just increase the speed at which you get to that place. And so you want to move this one very, not very much, because once you get to that certain position, if you start going too fast, your P constraint and your D constraint won't matter anymore. So mess with that very lightly. We were having some issues with the turn, but it's the exact same process. Just trial and error for now, and that should be it.